So as we pick up on example B here, let me do a brief refresh, okay? We are looking at trying to graph. Now, first of all, remember it is a cube root graph, right? So I said we're going to start with y equals x cubed, or cube root of x, excuse me. Here's our xy chart that we're going to use as our starting points. Then we talked about that negative out in front of the x means we have to reflect. It's reflect across the x-axis. This plus 4 at the end means we're going to move up 4. Okay? So, take it in steps. Some of you will want to combine steps. Some of you can do it all at once. You have to do you. I'm going to start with the original points. Okay, so my original points, let's graph these. -8, -2, so left 8, down 2. -1, -1. Left 1, down 1. 0, 0. 1, 1. And 8, 2. I guess I should have suggested maybe lightly or something. Okay, because now, what has to happen? What does reflect across the x-axis mean is going to happen? Which one is our x-axis? Horizontal one. So if you're reflecting across the x-axis, you are flipping across the x-axis. So anything that's above is going to go below. Anything that's below is going to go above. Okay. Now, I'm going to grab, I don't know, I'm just going to grab gray for right now. Okay, so what does that mean? -8, -2, it was below 2, now it's going to be above 2. -1, -1, it was below 1, now it is above 1. What about 0, 0? Stays. 1, 1, it was above 1, now it's below 1. 8, 2 was above 2, now it is below 2. Those are my current points. Am I done though? No, because now what? Yeah, we're going to take each of those points and move them up 4. Okay? Now I'm just going to count up from each of those spots. 1, 2, 3, 4. 1, 2, 3, 4. 4. 4. And 1, 2, 3, 4. Puts us on top of one of our original points. Okay, guys. Those green points are my new graph. Okay? Should look similar to the graph we graphed at the top of the page yesterday, but it's shifted up and it's upside down. Okay? Questions on that graph? As you get more comfortable with this, you may be able to combine steps and not have to do, 3 sets of points. But I'm at the point of the game where I don't want to lose anybody, right? Okay. Before we move on real quick, domain and range. Thoughts about domain? All real numbers. It's going infinitely left, infinitely right. So it's all real numbers, or it's -infinity to positive infinity. Okay. I don't know if I have room the way I did this. We'll make it work. Okay. What about range? Going to go infinitely down and infinitely up, yes? So it is also all real numbers, or -infinity to positive infinity. I feel like it's -infinity to positive infinity in Savas. Okay? But I'm comfortable with either or, so just know what you have to know for Savas, of course. And if you guys remember, I shared the secret yesterday, didn't I, that if it's a cube root graph, domain and range are always going to be all real numbers, or -infinity to positive infinity, correct? Okay. Let's flip to the back. Okay. We got 2 more graphs to do. Now, these graphs, we add a little bit to them. Okay? So let's look at the pieces here. As you look at C, we have to identify all those pieces. And there's several pieces, aren't there? So what pieces do you see here? A -2. And what about that -2? Okay, it's in front of the square root. Now, we just had a negative out front of the last one. What did the negative do?
They reflected it.
The negative was a reflect. And that negative there is still a reflect. What about the 2, though? Yeah, if you go back to that chart on the front of the page, and I don't want to keep flipping slides, but it's the A value, right? And that A value out front is a vertical stretch or compression. Because 2 is bigger, it's a stretch. Okay? What else? There's a +3. That +3 is under the radical, so what's that tell me to do? Left or right? Which one?
Right. Nope. Left.
Okay. Yep. Remember, the left or right is the one that's always opposite the sign, yes? Okay, and what's the 5 tell me to do? Up or down. Since it's a +5 at the end, we're going to go up 5. What is all this being done to? The square root of x graph. Okay, so, as I said, this one, there's a little bit more to it. We're going to start with the square root of x graph. Now, the trick is, because there's a stretch, I have to handle things a little differently. Okay, because a vertical stretch, instead of having all those normal points, it's going to stretch them up. Okay, so my graph that normally goes like this is now going to go higher up. So let's start by writing down our square root of x chart. We have that on the front side, yes? What are our square root of x values? 0, 0, 1, 1, 4, 2, and 9, 3. You said 0, 1, 4, 9, didn't you?
Yeah.
I'm with you. I thought, I got confused there. I was thinking pairs, you were giving me x's. I'm with you now. Okay. Those are our original x values, right? Now, the easiest way to deal with the stretch, and in this case, we can get the reflection dealt with too here, is that reflection and stretch is multiplying by -2. It's a vertical stretch. Are x's or y's vertical? Which ones go vertical? Those are my y values, right? So to do a vertical stretch and the reflection, what we're going to do is we're going to take each of our y values and multiply by -2. Okay? It's just going to be our y values, and we're going to come up with new y values. Okay? So we're going to take each of these y values right here and multiply by -2. So by multiplying by -2, we're going to take care of the reflection and the stretch. Okay. With this in mind, what is 0 times -2? 0. 1 times -2? -2. 2 times -2? -4. 3 times -2? -6. Okay, guys. We're going to take our original x's and our new y's. Okay? We're going to use those two values right there, and those are our starting points. Okay? And let's see, what do I want to put? This column right here, I need to label it.
Z.
Not Z. It was what? It was taking our y and multiplying by -2. So I'm going to call it, it's my -2y column. It's my y values times -2. So we're going to take these values right here and graph them. So let's graph these real quick. 0, 0 is still at 0, 0. Now, it was 1, 1. But now it's 1, -2 because we're stretching it. So we're multiplying it by a factor of 2. And the negative is making it go down. So right 1, down 2. It was 4, 2. Now I'm going to use 4, -4. Because I'm stretching it by a factor of 2 and I'm reflecting. And it was 9, 3. Now I'm going to use what?
9, 6. -6.
9, -6. Now, am I totally done though? No. It's easy part left. What have I not done yet?
Domain and range. Oh,
Before domain and range, we have to take these points we just made and move them left 3, up 5. So move left 3, up 5. You ready? So 0, 0. It was at 0, 0. Now I'm going to go where? Left 3, up 5. Can you do that with each point? Yeah. Okay. My point that's at 1, -2. I'm going to go left 3, up 5. My point that's at 4, -4. Left 3, up 5. And my point that's at -6. Left 3, up 5. And there's some other ways you could do that along the way. Okay, I reverted back to just moving each one. Okay, there's other pieces. So, this right here is our new graph. Keep in mind, what does the square root graph do? It doesn't go past that beginning point, does it? Okay, that beginning point is like an end point, and then it continues the other way and has an arrow there. Those are the tricky graphs. Not that you see a ton of those, but you have to watch for the stretches. And they're just going to stretch the y values. Now, Jocelyn wasn't going to let me forget. That's good. We do need to still talk real quick about domain and range. And I'm just going to squeeze them in right here. Okay, domain. How far left are we going? This is what?
-3.
-3. How far right are we going? Infinite. So my domain is?
Bracket.
-3 to infinity. Bracket on -3 because that is a point. It is included. Infinity is a parenthesis. Range. Okay. How low does this graph go?
-1.
Infinity?
Oh, yeah.
Because what's happening? As this graph is going right, is it getting lower and lower and lower?
Yeah.
So it goes as low as -infinity. How high does it go?
-3. Nope.
No. It goes as high as, what's the y value here?
5.
And that is a y value of 5. So -infinity to 5, and 5 is a bracket. Okay? Okay, so those are a little bit tricky domain and range when you get that square root graph all flipped around, but look at your graph, use it, okay? Okay, ready for D? I realize that 2-hour delay threw me off yesterday. I'm gonna have to push to make sure we get through this. Okay, gather all the information, folks. What do we see on D? Okay, the 2 out front is going to be another vertical stretch. So we're going to practice dealing with the stretch again. It's a cube root. So when we think about our XY chart over here, we're going to talk about a cube root. A -1 under the square root, left to right opposite the sign, so right 1, a -3 at the bottom, down 3. Okay? Okay, guys. With that in mind, I'm going to start by listing my original graph of XY charts, which are my cube root. So if you go back to your front page, grab your cube root ones. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. I didn't make those up. Those were what we did yesterday, right? They're on your front of your paper. Now, what are we doing with each of these Y values? Multiply it by 2. Okay? We're going to multiply each of these Y values by 2. And it's the Y values because this is a vertical stretch. I should probably be specific. It is a vertical stretch. That's why it's the Y values. Okay? So when we multiply our Y values by 2, -2 times 2 is
-4.
-4. -1 times 2. -2. 0 times 2?
0.
1 times 2.
2.
2 times 2.
4.
Okay, so we're going to use what? Your original X with your new Y's. We're going to graph those. So we're going to graph -8, -4. So left 8, down 4. -1, -2. Left 1, down 2. 0, 0. 1, 2, right 1, up 2. And 8, 4. Right 8, up 4. Am I done? No, because now what do I need to do?
Write it 1 down.
I need to take those points and move them. Right 1, down 3. Okay? And if you're someone you're like, yeah, I didn't graph the original points. I went straight to the final points. I can see that in my head. As I said, more power to you. Okay, so each of these dots moves what? Right 1, down 3. 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 Okay. For me, it's the purple points. It's stretch, so it's a little bit bigger curve, isn't it? But it didn't reflect this time, so it's still right side up. Okay. What's the domain?
All real numbers.
What's the range?
All real numbers.
Right? The cube root is going to have both domain and range, all real numbers, or if we're writing it in interval notation, we're going to say -infinity to +infinity. sorry, I'm short on room, so you're getting the short version here. Negative infinity to positive infinity. Okay? As I said, you get to ease your way into graphs. In Savvis, the graphs are multiple choice today. You're not actually graphing them by hand, so you'll be able to ease your way in. Okay, but when we talk quiz next week, I'm going to ask you to graph these by hand. So that's why we're going over it, okay? Questions I should answer here. Okay. Next section. In this section, we're being asked to rewrite these graphs so we can figure out what their transformations are. Are they moving left? Are they moving right? Up, down? Are they reflecting? Are they stretching? Okay. Now, when we talk about rewriting these functions to make it easy to graph them, okay, describe the graph, it really has to do with whatever's underneath the radical. So as we look at the first example, A, we're going to start by looking under that radical. The square root of 4x plus 16. My hint to you is to look and see, what do you see underneath that underneath the square root? What do you see in both terms?
Perfect square.
Okay. They both happen to be perfect squares here, yes? But more importantly, what do 4x and 16 have in common? They both divide by 4, which 4 is a perfect square, yes? So, follow with me. What we're going to do here is we're going to take, under that radical, think GCF. They both divide by 4, so I'm going to factor out the 4. And when I factor out the 4, 4x divided by 4 is x, plus 16 divided by 4 is 4. And then the plus 7 is still just hanging out outside. Now, here's the nice part. Because this is 4 times another quantity, we can take the square root of that 4, since it's just a single number, and put it out front. So can you visualize what that's going to look like? The square root of 4 becomes what out front? 2. What about x plus 4? Well, I can't take the square root of that 4 because it's attached to the x plus 4, so it stays under the radical. And then you have a plus 7. So when they talk about rewriting the equation to make it easier to graph, this is easier to graph. Because now I just know, oh, it's square root of x. I'm going to move it here and here, and I'm going to do this. And that's what makes it easier to graph. So the rewrite direction is this right here. Look for a perfect square, factor it out, take that square root, and then rewrite it. Now, it does say describe the graph. What are the transformations you see? That's what I'm looking for when I say describe.
A stretch.
Stretch by a factor of 2. Left, 4, up 7. And what is this all being done to? Which graph? Square root of x graph, yes? So how I have this written out on my paper, the graph of y equals square root of x is vertically stretched by a factor of 2 and translated left 4 units and up 7 units. I know, a lot of words. You can shorten that some, but key points. Get all those key points. Okay? So can I fit this all in here? Let's see. The graph, start by stating what graph are we talking about? Y equals the square root of x is vertically stretched, or has a vertical stretch, whatever, by a factor of 2, and I like to use the word translates. Moves, shifts, put a verb in there though. I know, darn English in your math, but you can do that. And I'm going to say translate left 4 and up 7 units. So we did a rewrite and we did a describe. Now in Savvis, realize it's going to be picking the description that they give you that's correct, because you don't get to write out in Savvis, but be able to put all those pieces together. That wasn't too bad, was it? Other than you had to write words in math. Okay, B. G of x equals negative square root of 9x. Thoughts? Well, start with how can we rewrite this? What do you see under that radical? A 9, yes? And what do we know about the square root of 9?
3.
It's a perfect square. It can become 3 outside. So you can think, I mean, basically what we're thinking about is this is, under that radical, it's 9 times x, right? The square root of 9 is 3, so I can rewrite this, still with negative out front. I can move the square root of 9 out front as a 3, and then times the square root of x. When they ask you to rewrite, that's what they're looking for. They're looking for you to be able to see the perfect square and factor it out, take that square root. Because now, this would be easy to graph by hand. What are the pieces that we're going to see here? What do you see, Braden?
Vertical stretch.
Okay, vertical stretch by a factor of 3. The negative out front says we reflect across the x-axis. And what graph is this all being done to? Square root of x. Because here's the thing, if you can describe something to me, I need to know what graph I'm talking about. Okay? So, I'm going to say the graph y equals square root of x. And I think on this one you could do the vertical stretch or the reflect. It doesn't matter the order here. So, this graph is vertically stretched by a factor of 3, and the negative is out front, so it is reflected across the x-axis. Okay. C. What do you notice on C?
Cube root.
We're talking cube roots instead of square roots. That's good to know, right? What do you see in common as a GCF under our radical sign? What'd you say? Negative 27. I'm going to factor out a negative 27. So now, kind of like on example A, I'm going to start by factoring it under the radical. So cube root. Because the first term is negative, we like to factor a negative out. They both divide by 27. So negative 27 times x. Then what is 81 divided by negative 27?
3.
Or minus 3. Okay, guys. What is the cube root of negative 27? Well, Well, the cube root of 27 is 3. It's the second thing down my paper, right? What's the cube root of a negative? A negative. So what's going to go out front here is a negative 3 times the cube root of x minus 3. Because I obviously thought you needed a bunch of 3's in this problem. Okay. It's all right. We can do this. What do we have going on? Which graph are we starting with? This is the graph y equals the cube root of x. Let's start with the pieces out front. What's going on out front? The 3 is a vertical stretch by a factor of 3. What's the negative going to do? Reflect across the x-axis. So let's see. This graph y equals cube root of x is vertically stretched by factor of 3, reflected across the x-axis, and we did our reflection, our stretch. It was a cube root of x. What's the piece I'm missing? What 3?
Down.
Not down 3. Right 3. Why is it right 3? The minus 3 is under the radical. So left or right, opposite the sign. So we are going to translate right 3. So translate right 3 units. Okay. We're doing good. I think we'll be fine on the bottom section. Okay. Make sure you have what you need here. And then start looking at that bottom section. The bottom section asks us what radical function is represented in each graph. So we're writing the equation now. That's what we're doing. We're writing the equation. Okay. As we look at A, what kind of graph is this? Is it a square root of x graph? I'm just going to write some little notes to myself here. That's a square root of x graph, isn't it? Okay. Where is it moved? It normally starts at 0, 0. Where is it starting at now? It moved right 1 and up 1. Any reflection? No. The big thing to check, is there a stretch? No. And here's what I would think. Okay, 0, 0. Our next point should be over 1 up 1. Our next point should be over 4 up 2. Does that fit the right mold? Yeah. So it's a normal graph. Write an equation with this information here. I'll give you the starting point. Y equals. Okay. How do we show right 1?
Plus 1.
And where is that plus?
Minus.
Yeah, I started to agree too soon. I fell for it, hook, line, and sinker. Okay, right 1 is minus 1 under the radical. How do we show up 1?
Plus 1.
Plus 1, and it is outside the radical. You seem to follow that okay? Okay, ready to try B then? What stands out about B?
Deflected the cube root. No, it's not. I don't even know what it's
See?
Can we agree it's a cube root graph? It goes both ways. We don't have an endpoint. Okay. Does it go the normal right way? Yeah, it comes from the left, goes up, comes right, yeah. Okay. Our center point is normally at 0, 0. Where is it at now?
1, 4. Nope.
No.
Oh my gosh, I think I'm just gonna stop dancing today.
The center point where it does its turn is right there at the -2, 3. Because think about it. This -1, 4 is over 1, up 1. And is there a over 1, down 1 point? There is, right there. Okay, so those 3 points kind of make the setup. That right there is your center. So where does this graph move? It moves left 2, up 3. Okay, y equals, don't forget this time we're starting with cube root of x. What goes under the radical? Left 2 is plus 2 under the radical. Up 3 is plus 3 outside the radical. Good. It's not as bad as it looks, is it? I know graphs, everyone's like, oh, bad. Not necessarily. Okay, we have to be careful on some of these, though. What is this one? It's square root, yes? Normally a square root starts at 0, 0. We're starting at -5, -4. I love when they label it for me. So where did my graph move? Moved left 5, down 4. Now, we have to decide if there's any type of stretch. I say be careful here because what annoying thing did they do? They labeled vertically by ones. 1, 2, 3, 4, -1, -2, -3, -4. What'd they do horizontally? By 2s. So here's the deal. I see a point right there. Is that up 1, over 1? And it is. Because up 1, you're going up a whole box, right? From -4 to -3. Over 1, you're going half a box. But half a box takes you from -5 to -4. So it's a normal graph. It just doesn't look normal. Am I making sense at all?
Sure.
We don't like this one as much, do we? Okay. But that's, if you think about what these ordered pairs are, it would work out. Okay? So, y equals, we said it was square root of x, and then what? Left 5 is plus 5, down 4 is -4 outside of the radical. Okay. 2 more. What kind of graph? I know, we can do this. What kind of graph is it?
Flexion. Darn it.
No.
Square root or cube root?
I just really want to have a flexion.
Sorry. Okay, this is a cube root. Now, did it move any? It's still centered at 0, 0, isn't it?
Yes.
But where are my points supposed to go from 0, 0? They're supposed to go
Up 1, over 1.
over 1, up 1, and down 1, left 1. Do they do that? They go up 2. Up 2 instead of going up 1. We just doubled how much we go up. So this is a what? It is a vertical stretch by a factor of 2. How do you write a vertical stretch by a factor of 2?
2 cube root of x.
You put the 2 in front. So y equals 2 times the cube root of x. Okay. And E. Yeah, I love it. They gave us no points.
Yay.
But we can see. Okay. What kind of graph is it? It's a square root shape. Normally it starts at 0, 0. How'd it move? It moved over right 1. Now, what's a normal graph do? It normally goes over 1, up 1. What's this do? Over 1, up 2. If it goes over 1, up 2, and it's only supposed to go up 1, what just happened? Yeah, this is a vertical stretch by a factor of 2 again. So, equation, y equals, vertical stretch of 2 goes out front, times the square root of x, minus 1 for a right 1. Okay? Make sure you finish those in your notes. There's homework out there. It is due tomorrow. Work to get it done, okay? That's lesson 5.3, and then we'll be looking at some quiz review. Okay?